Okay, so now I'm at the phase where I've made this skeleton that's bound to Homer here, and I want to export this skeleton into a JSON file that you can load in Homework 3. And that's where you're yourself going to program the bones moving and update the vertices according to which bones they're bound to. Now, even if you're not doing Homework 3 in my class, you might find this video interesting because I'm going to show you how to script in Python on top of Blender to drill down into some of the data that's there. So in order to do this, I am going to switch back, I guess I'll go back to object mode here, and I'm going to go up in this panel up here, and I'm going to click on scripting. And so notice that totally changed what I was looking at here. I still have a window pane where I can see the 3D object, but now it brought up this window here where I can actually type things in. So I'm going to click new here, and I'm going to call this export.py. And so I can start coding up here, and I've also got a console down here. So what I'm going to do now actually is something I often do when I'm playing around trying to figure out sort of what's going on with the objects that I have in my scope. So in Blender, you can actually access a variable for the scene by, actually first I got to import this library called BPY. That's going to allow us to drill into Blender objects. And then I can say, sorry, let me just move this over a little bit, make it a little bigger. I can say scene equals bpy.data.scenes. And the name of our scene is right now just capital S scene. And so if I look at that, so that worked. And if I type a dot and then type tab, it shows me everything I can get here. And so what I want actually is to drill down a little bit further into objects and extract my armature. So if I get stuff to work, I'll start to copy it up into my Python script here. So I had import bpy, and then I had scene. So I'll just copy this line over here. So I had that, and then let's check. So if I say scene.objects capital A armature, okay, that seems to have given me the object corresponding to this, so that's good. So I'll go ahead and say that. I'll say, let me save that in a variable called armature. So I'll say armature equals that. So just drilling down even further there. And now what I want to do, so for this assignment, I'm just going to, so let me go back so I can show you here. I'm actually just going to export each joint. I'm not going to export the bones directly. I'm just going to export the tail of each bone. So what I'll do here is so it turns out armature, within armature, I can drill down into the bones. I mean, if I look at that here, actually it looks like it's in a variable actually called pose. So let me see that. So if I say armature dot let's see, pose. Okay, yeah, lowercase p pose. The cases are a little interesting here. This looks like it's uppercase, but I guess this object's lowercase. So if I say pose, that is going to allow me to get down and drill into the bones. So let me say, yeah, if I look within the pose and I drill within that, there's a variable called bones. Okay, so what I'll do is I'll loop through. So first I'll just loop through here. I'll say for, I might as well just type the code in here now. I'll say for bone in armature.pose.bones. And okay, if I look at each of these, so let me just say maybe b is equal to next armature.pose.bones. That didn't work. Okay, it's not an iterator. Let me see, is it a list? If I were to say this. So you just play around with this stuff. Okay, so that was like the first bone. Okay, so within the bone, I've got a bunch of stuff, but what I want is the tail. So we're just drilling further and further down into this. So yeah, let me say b.tail. I look at that, and finally, I've got some geometric information here. So that is going to give me a vector And if I look at that, that's got a bunch of stuff here. But what I really want is the x, the y, and the z coordinate. So let me create actually a dictionary. And let me make the keys in this dictionary be the name of the bone. So the bone actually got the name that I assigned to its tail before. So if I say bone dot, I think it's name. Whoops, what did I do? Okay, I need the, okay, I call it b. Okay, b dot name. Okay, good. So I happen to select root. That was the first one. So that's the first bone, although I'm going to store its joint, so I need to get the tail. So I'm going to say, okay, so the name is bone.name, and then the position is bone dot, I had it a second ago, bone dot, right, okay, so I got to go to the tail, so bone dot tail dot, okay, so now I can get the x, the y, and z, so I'll just say bone dot tail here. And what I'll do is I'll say, okay, let's make a new entry in this dictionary. I'll make it with the name, and the value will itself be a dictionary with some information. So one of the things I need is the position. And now here's where I have to be a little careful, because if you look at the coordinate system that Blender uses, positive x is right, that's what we're used to. But actually positive z is up. Whereas we're using the OpenGL coordinate system, so positive y would be up. So I got actually, the way I'm going to save this, exporting it to our program, I'm going to have to say pos.x, that matches. But what we consider y, positive y, Blender actually makes positive z. And then to keep this a right-handed coordinate system, what that means is what we call positive z, which would be coming out of the screen, is actually negative y. And so I'll have to say negative pos.y. This kind of stuff happens all the time. Nobody can ever agree on what coordinate systems to use. So anyway, I'm just showing you, how it is in the real world, I guess. Okay. All right, so we've got that information. But I also want to store, in order to make this a proper skeleton, I need to remember the topological information about it. So I need to remember what bones are connected to what bones, or which joint do I get to next. So if I look at bone.children, turns out there's actually I called it B in the console here. If I look at b.children, I'll see a whole other list of bones here. And so what I can do is actually say joints name children, make that an empty list, then I'll say, okay, for C in bone.children, let me go ahead and say joints name children dot append c.name. Okay, so I should probably, I've done a lot here. Let me go ahead and just print that out and see if that worked. So I ran this, and actually got to go back and look at my own console here. Okay, so this seems to have saved information that I'm eventually going to export to JSON. That's great. In fact, I can do that now. So let me go ahead. If I import JSON up here, turns out there's a nice library in Python to save to JSON, because JSON is basically already like the format that Python objects are in. So if instead of printing I say json.dump, turns out the object I want to save, and then I need to open a file pointer. So I'll call this homer.json. So I open a file pointer for writing. I run this. Didn't have any errors, that's good. If I go into my folder here, I see now there's a JSON file. So if I right click on this, open it with some browser, like Firefox, it'll bring up this really nice interactive tree viewer of all the JSON data. So for example, I see that this root here is a top level object. I got the position object within that. I got the children, which is a list of those children there. Got the right shoulder, neck, upper abdomen, left shoulder, and if I go back and look, that's exactly right. So I got my right shoulder there, neck, upper abdomen, left shoulder. Those are all connected to the root. So great, looks like we got all that information out. Now we need to get the weights out. Okay, so we need to figure out, okay, so for each bone there's a certain set of vertices that bone influences, and it influences them different amounts. And so if you remember, when I bound the mesh skin to the skeleton, it nested it under here, and if I look at it, it actually now has these vertex groups, along with it. So the Homer mesh now has these vertex groups. Each of these vertex groups is some subset of the vertices on the mesh that particular bone controls. So I need to get down and I need to find those vertices, and I need to figure out what their weights are. So what I need to do actually is I need to get the mesh out of the scene now. So if I say mesh is equal to scene.objects, and it's called Homer. Whoop. So I'm going to try this in the console first. Okay, now if I say mesh dot vertex groups, turns out that's lowercase there. This is something I can get to, and this is a dictionary. So I see now. Okay, if I look at the keys of it, I've got a vertex group for each one of the bones, and so what I'll do is I'll loop through that. I'll say, okay, so for bone, and then I'll say group in. So yeah, let me copy this over here. So my code here, I'm going to make a definition of mesh. So I'll say for that in mesh.vertex group.items. So this is how I loop through the keys and the values in the dictionary. Okay, so now what I need to do is, so let's look at an example here. So if I were to say mesh.vertex group.values, let's look at the first one. Okay, so let me assign this to a variable here so I can take a look. Now, this is a little bit messy. The only way I've figured out how to do this well is to call this method called weight, which takes a parameter, which is an index of a vertex in the mesh. A lot of them aren't actually bound to this bone, and so I gotta kind of figure out which ones are bound to the bone. And the best way that I know of how to do this is just to loop through all the vertices in the mesh, and then, you know, do a try catch. And if there's no exception, oh, then it actually was there. So to get the number of vertices in the mesh, I have to say mesh.data.vertices. And if I look at the length of that, so see in this Homer mesh here, there's about 10,000 vertices. So let me go ahead and say n vertices is equal to len mesh.data.vertices. I'm just going to loop through all of them. So I'll say for I in range n vertices. Let me try to call this method on this group for the bone. So I'll say, I'll try to say group.weight I. So I'll say w is equal to group.weight I. And if that works, great. Otherwise, I'll just keep going. I'll skip, so I won't crash the program here. Okay, so, but I want to save this information. So what I'll do is I'll create another key value pair in this joint corresponding to this bone. So remember, the joint at the tip of the bone is what actually holds the data in my object here. So I'll say joints bone. So just to check the, if I go back up here, the key is actually a string. Oh, yeah, anyway, the key is a string. And so I can say joints bone is equal to joints bone weights. That's going to be a dictionary. Okay, so I'm going to store a dictionary, another dictionary, inside of this particular bone joint pair here. And that dictionary is going to hold this information. If I find that there is a vertex that is bound to this bone, I'm going to add something to that dictionary. I'm going to say, okay, joints, bone, weights, I equals W. Okay, so I'm going to say, okay, vertex I. So the vertex index is the key, and I'm going to make W be the value. So let me try that, and let me actually move my JSON down here, so I'll save this to all of it to a file. I have an attribute error. Object has no attribute vertex group. I meant to say vertex groups. Let's try that again. All right, good. So let's have a look at this again in the browser. So now there's a lot more information here. In addition to the position and the children, I have weights. And so here are all the vertices that were actually bound to the root. Actually, I hope it's not too many because the root is not something that I'm going to move in the animation. But if I look at, let's look, probably the upper abdomen has a bunch, I bet. Yeah, so look at how many are bound to the upper abdomen. And so these weights here are the influence. So the number between 0 and 1. If the number is closer to 1, that means that this bone has a higher influence on that particular vertex. And so what you're going to do in the assignment is extract this information. And you're going to find the top 3 weights for each vertex, which bones they correspond to, and those 3 bones are the ones that are going to control that vertex. Okay? But for now, this is great. We've successfully extracted this information into a JSON file, and that's exactly the JSON file that's going to be in the homework. So you can repeat this process to extract information from Blender for your own mesh that you've created a skeleton for. So I hope to see some cool stuff in the art contest. And those who aren't involved in my class, I hope that this was served as a nice example of how to use Python to do some scripting with Blender and how to play around in the terminal here and get stuff. All right, take care. Oh, I spoke too soon. There is actually something I need to fix. So if I were to export this right now as it is, and then go into my skin.js file in the homework, and let's say I was going to move, let's say I'll take the right wrist and move that up using Fabric. So you're going to implement this. So if I move that up, and then I open up skin.html, which actually, by the way, I should mention, this is where you, if you were going to change what you were using, you would load the auth file here. So you'd use MeshLab to convert your own mesh into auth file. And you would load the JSON file that we just made here. So if I do that, and I open this up, I get something pretty amazing, actually. So I was supposed to raise Homer's arm up, but something's gone terribly wrong here. And the reason is because if I go back to Blender here, I notice, let's go back to layout here, there is this little offset. And if you remember, when I did the mirror of the bones, they went off in a weird direction. So I need to actually move Homer to be centered and the rig to be centered back there. So I'm not sure why it did this, but I'll show you. It's happened sometimes. I'll show you how to fix it. So if I click on, so I go back to object mode, click on Homer, and go up to this object menu here. And let's see, where was it? If I go to, okay, clear origin, it moves me back. You could also move it manually, but this will get it back exactly where it's supposed to be. So now, unfortunately, I do have to move this armature back manually, so I'm going to go back to edit mode there. Type A to select the whole thing, type G, and try to get this aligned again. And it's mostly okay, I just got to move it over this way. Actually, let me undo that for a second, because if I type 3, that'll move me like this. So that was 3 on the number pad. And now if I type G and then Y, I can move it exactly just along the Y axis there. Okay, so now I think I got it back. Maybe just need to move it down a little bit. That seems pretty good. So now let me run that code again. So I'll save this, and let me go back to scripting, run that code again, and we should see a big difference here. Oh, okay, one more thing. We do need to, because this is moved, we do need to recompute. Okay, so let me save this. Go back again to layout, object mode. I'm going to click on this. I have to recompute the binding now. So click on this, and then shift click on the armature. Oh, left click on mesh, shift click on armature. So I'm trying to do there. Can I finally get it? Mesh. Okay, that was the armature. Mesh. Armature. Okay, finally. So now I type Control P, and I'm going to do the with automatic weights again. And unfortunately, it just moved it back here. So Blender's a little bit weird sometimes. It's great, but it's also weird. So I guess I have to go back to and go back to object here and say clear origin. Okay, finally. So let's see if that worked. If I go back and run the script now. So yeah, this looks more reasonable. I think I just maybe raised that a little bit too high. If I go back and I change this from a 0.4 to 0.2, okay, that seems a little more reasonable. Maybe I'll select his left ankle and move it forward or something. Let's try to do another thing here. So I'll say let's select the left ankle. So ankle.l. And I guess, yeah, we'll try to move that out a little bit. So z index will add a little bit to, let's see if that does it. Okay, yeah, so that moved the foot out slightly. And you can see it in the skeleton down here. So he's about to kick something. Anyway, so this is, yeah, this is what you'll play with in the assignment. And so hopefully it made sense on how to fix that up.